So we're going to talk about piecewise functions today, and I'm going to use your notes. You'll notice that on the Canvas course, there's a pretty PowerPoint that goes along with this. And for whatever reason, I can't get it to pull up on my screen and allow me to write on it because, anyone that knows me knows the story of my life is that my computers are possessed. So, of course, I can't do it. Anyways, so I'm just going to use your notes and I'm going to fill them in as we go along. So piecewise functions are defined by more than one equation. So this should be more than one equation for unique intervals, which we call the domain or the x's. And so when we're graphing the piecewise functions, we want to first decide what pieces that we have, okay? And so in order to decide what pieces that we have to I'm getting there, y'all. I'm sorry. Um, we have to first decide how many pieces we want. So how many different pieces are part of our drawing, okay? And so we decide how many pieces we have. And then we identify the parent function of each piece. In our calculator, which is our TI-85, we would create a table for each piece by hand, or in the calculator, we would do y equals, and we would do second graph to get the table. Be sure to include the boundary points. In Desmos, we would put each piece in one at a time. With the domain in these funky curly brackets. Then we would draw each piece and complete each piece based on our table, if we were doing it by hand, and we would put the pieces together. That's table. Remember that an open dot would be greater than or less than. That means don't include the values. And a closed dot would be greater than or equal to or less than or equal to, and that means to include the values. Okay. So here we have two pieces. We have this square function. So this is a quadratic. So we know this is a parabola, right? We have this linear function. So I'm going to make this a different color. I'm going to change this to, let's do orange here. So this linear function. And so with this parabola, we know that the parabola is shifted down 4. Didn't switch colors. Hold on. The parabola is shifted down 4. Okay. And so if we were to put this in Desmos, we could see that. Let's see if I can switch over here to Desmos. It's not going to let me switch. Okay, I'll switch over to Desmos and show you. Anyway, so this is a parabola shifted down 4. 1, 2, 3, 4. And it starts at -1. So it's the parabola shifted down 4, starting at -1. And so if we plug -1 in here, we get -1 squared minus 4 is 1 minus 4 is -3. So it really starts right here. So these two dots don't include it, and the parabola goes this way. So we're not going to include these two dots. Then this is got a slope of 2 and a y-intercept of 1. So a y-intercept of 1 and a slope of 2, starting at -1, goes this way. So this equal sign means closed dot here. And this greater than means open dot here. So this should have an open circle here. And so this would be our graph. And I'll show you what that looks like in Desmos. So over here, we have two lines. We have this line, which has a slope of 2 and a y-intercept of 3. It has an open circle, and it's on the left side of 0, right? Because it's less than 0. So the left side of 0. So 1, 2, 3, open circle, and it goes down to 1, down to 1. And so here's what this graph looks like. And this one here, if we switched it to here, has a slope of -1 and a y-intercept of 3. So it has a closed circle, and it's the right side of 0. So at 3, it's closed in now. It goes -1, -1, -1. So it goes like this. For here, we have a parabola shifted up 1, open circle, and it's the left side of 0. And so it's shifted up 1. It's the left side of 0. This is a line that has a slope of 1, a y-intercept of -1, a closed circle, and it's the right side of 0. So it is, this should be an open circle. It's hard to see, it's open. So this is a closed circle, and the graph goes this way. This is a line with a slope of 2. This is a y-intercept of 1. It has a closed circle. It's left of -1. So 1, it would start here and go 2 and 1 would go to here. So this is actually where it's starting at. So it would be right here and go down 2 and 1. So it goes this way. This is a parabola shifted down 2. So this parabola would actually start here and go this way. But we have to include this -1, right? It has an open circle. So if I do -1 squared minus 2, that's 1 minus 2 is -3. So that tells me one minus 2. Oh, nope, that would be -1. Sorry. That tells me that this should go to here. And those would connect. Okay. Number 5. So we have a line that has a slope of 3 and a y-intercept of 2. And it's to the left of -2 with an open circle. So the best way to do this is to plug in this -2 here. So we get 3 times -2 plus 2. -6 plus 2 is -4. So that tells me at x equals -2, I get the y value of 1, 2, 3, -4, and that's an open circle there. And then I can use this slope of 3 to go 1, 2, 3, and 1, and that would be the line right there. Okay. Then for this part, I could plug in -2 here and 1 here to get this line. So negative of -2 is +2. So at x equals -2, I get +2. And I get a closed circle because it's equals to. At negative of +1, I get -1. So at +1, I get -1. And that's an open circle. Oh, that's hard to see. Let's do that again. And so I connect those dots. So that gives me this blue line right here. Okay. Then for this last part, I know this is a parabola shifted down to, but let's see where it starts. So if I do 1 squared minus 2, 1 minus 2 is -1. So at 1, it's at -1. So that gives me this point right here. It does this. So I can use these X's to plug in. These are my boundary points. So these are also my ends of my graphs. So that can help me to see where my graphs start and end, okay, if I'm having to graph them by hand. So over here, if I want to know where the graph started, I could say 3 plus -3 is 0. So at x equals, this is my x, at x equals 1, 2, -3, I got 0. Well, I got this point right here. And at 3 plus 0, this is 0. So 3 plus 0, I got 3. So when I plugged in 0 for x, I got 1, 2, 3. And both of those have no lines on them, so I get open circles. So that would give me this graph right here. So for this function here, this is x equals 0. And remember, this is f of x. So this is y equals 3. So this is actually the point 0, 3. So 1, 2, this is this point 0, 3. This is the square root function on the right side with an open circle. So it would normally go like this. And so it is an open circle here going over like this. Almost done here with the drawing graphs. So example number 7, we have this linear graph with a slope of 1 and a y-intercept of 2. Excuse me, I say 2 and it's really 3. And I wrote 1, so who knows what I was thinking. So then it starts at -2. So if I plug in -2 plus 3, that's equal to 1. And it's an open circle. So at -2, I get +1. I get a slope of 1. So this is this graph going this way. This graph here is at 1, at x equals -2, it's 1. Well, so that's this point here. And at 0, it's 1, and that's an open circle, so that's here. So these are connected dots. And x cubed on the 0 side, so that's this part of the graph. So that's this, remember this graph, but I only want this part of it. Over here, this is the quadratic, the parabola shifted to the left one. So it would be this at 0, 0 plus 1 squared is 1. So it goes to here. And it's an open circle, so this goes to here. This is the absolute value graph, so that's the V graph, right? This is shifted to the right 2. So if I plug in 0 here, the absolute value of 0 minus 2 is 2. So at 0, it's 2. At 4, the absolute value of 4 minus 2 is 2. So 1, 2, 3, 4 is 2. It's shifted over to, this should actually be an open circle here. And so this graph looks like this. And this graph is the square root graph. So at 4, the square root of 4 is 2. So it goes here and swoops over. So that's how you would draw. You would just draw each piece. And I'm going to show you these same graphs in Desmos and how you would draw them in Desmos.